Okay, coming to you live from the Jackson Girls Playroom. I wanted to talk about factoring a trinomial that has a leading coefficient. We haven't had any of these yet, and there's a trick, not a trick, but there's a step to this process. It's actually on the pink sheet that I gave you in class, and we'll talk about it here today. You should have the note sheet. There's a white note sheet that goes along with this. I'm going to go through probably 5 or 6 of these in different videos, and I'll walk you through the steps here. But the process is going to look, the process is the same. Everything that we've done up to this point to factor is going to look identical to this, okay? There's just one thing at the very end that we have to do, or that changes a little bit. So remember that we're supposed to multiply these two numbers together. Now before, this was always a 1. So when we multiplied it times that, we were just listing the factors of that number. Well, now we're multiplying 3 times 5 and we're getting 15. So when you go off to the side and you start listing all of the factors of 15, okay, 1 and 15, negative 1 and negative 15, 3 and 5, negative 3 and negative 5. Once we come up with that list, we're still looking for the numbers that add to be positive 16. What numbers are those? 1 and 15. So when we go to our box method from here, okay, whatever this is still goes here. Whatever this is still goes here. And those two numbers that we find, those go here and here. Okay? Now, here's where things get a little different. In every single problem that we've done up to this point where there was no number here, we just had x and x, right? Because we were talking about the area model. But we changed that towards the end to say we're pulling out the greatest common factor in each one of these rows and columns, right? That's really important. And that's where you're going to see that change. So let's start here. 3x squared and 15x. What is the greatest common factor of these? Okay, this goes back to what we started with last week. This is divisible by 3, so is this. So the greatest common factor involves a 3, and they both have at least one x. So I'm pulling out 3x. So again, before this was only x squared, and it was always just x and x. But now because there's a number here, a lot of times we're going to be pulling that number out and writing it next to that x. Now let's look here. What do the numbers 1x and 5 have in common? The only thing I could pull out from each one of these is the number 1. Okay? When you look here in this column, what do we have in common? A 1 and a 3. So their greatest common factor is 1. And an 1x here, 2x is here, so I can pull an x out this way. What's the greatest common factor of 5 and 15? 5. So I'm pulling out a 5. So the process is the same. The difference is once we put that number here, in that what we call the leading coefficient, we're going to be pulling numbers out in these directions, here and here. There might be a number that I have to pull out as well. But when I go to write my final answer, it's still these two numbers together, 3x plus 1, and these two numbers together. Now I'm going to write 1x plus 5, but we don't really need this 1 to be here in front of the x. We do need this one because there's a 1 there and nothing else. But you don't have to write the 1 next to the x. We weren't doing that before. You can leave it there. It's not wrong, but we really don't have to have it. So the factored form of that trinomial is 3x plus 1 times x plus 5. All right? Another example coming up next.